All right, this is our room. This is the whole thing.
The room closet.
Yep. So we got one workspace here. We got the field. We got another table, and then we got our trophy rack slash tool stuff. And then
we have the shelving over here that has the rest of our parts.
yep.
Which got it.
And made these.
It's really warm, really crowded,
Yep.
really fast.
We have to leave the door open because
Well, when we get the bops going in here,
if you imagine 6 or 8 people in this room, in this little area.
yes.
These are our world's robots. They are basically identical. And this one is the yellow one and the blue one. And the only differences are these things to stop us from going in the goal, 8-tier hang, oh, and the drive. Drive did. Oh yeah, those pistons as well.
There's a difference on the drive. On this one, the wheels, all wheels touch the ground. On this one, we have 2 elevated ones in the middle, so that way we could mount the barrier easier.
Yep.
And then the wings have these.
Oh yeah, the
poly
wings.
carb sheets.
And these are snapped beautifully.
They got poly carb ones. But
Yep.
it's good.
So here, let's go over the drive first. So these are printed gears. These are 25 tooth and these are 19 tooth. The RPM is 456. So it's an 8 motor drive. You can see the 8th motor kind of up there. It's on custom mounts, so you can kind of see
Custom mount right there.
these are printed out of polycarbonate so that we can use basically that as a material for the bearing. So if we printed it out of like something else, it might wear down.
And they do it on both robots.
Yep, and we had no problems with these. These gears are also polycarbonate, along with this stuff, and this is just PLA. And this is ABS, because
And then of course,
Polymaker.
the TPU.
oh yeah, the TPU. So everything that would break on our robot, or like be in contact, is made out of TPU. So like these hard stops are made out of TPU so they can be squishy. These hard stops are TPU. And that goes for both
Same things
robots.
on this robot. Back TPU, these are TPU. We have, once again, the same parts in the front. We've been using TPU kind of throughout the whole season, just because it is easier for like compression and stuff too. So when we're shooting, we didn't have to be lined up perfectly because this molds around the tri-ball.
Yep.
And then it would launch this one. So I could be slightly off while match loading, and it would still find a way to get it in the catapult to shoot.
Yep. And speaking of the catapult, this is a 33 RPM here. Let me put the hang up.
Here we go.
So this is a 3 motor catapult. Do you want to explain why we use 3 motors?
So we were gonna use 4, but then I was programming and we hit the pole and I broke the motor. Like the housing just was destroyed, and then we don't have any more motors. So 3 motor, because why not?
So these originally had, our hang originally was going to be wrapping around the bar to get D tier, and that's why our hang is like the tallest thing on our robot when it's not up. And that would require 4 motors because we ratcheted our catapult.
We had 2 flex wheels here, and then
Yep.
the 4th motor went there, and then it would ratchet. So then our robot would actually rotate and sit like that at the end of the match.
But we couldn't get enough compression for that to work, even with these gigantic pistons. But the pistons worked well because we didn't need that many rubber bands to make our hang just so hard.
They were extremely consistent, so consistent B tier.
Yep. Our hang, do you want to explain how we control our catapult?
Oh, okay, so on the catapult, we have a distance sensor right here. And so not a lot of teams in VEX use that, but basically you can code it to go down to a specific distance away from, it's basically just a laser and it reads this piece of plastic here, and so you can set it to stop at a certain distance, which then you're gonna match, it'll automatically reset the catapult every time it's fired. So that way, the drivers have less to think about, and it's easier, it's more effective than a limit switch or a button, in my opinion, just because those are clunky to work with, and this you can just place it to where it has something to read off of. It's out of the way.
Yeah, so like we could have our catapult go down to here, this position, for an auton, and then we can get
sweep the travel out of the corner, and then we go up, and then you can reset it to a certain height.
Yep, and this is just a demonstration of the catapult. Yep, picks it up. We should explain the intake. So this is basically just a high school intake. So with our last robots, we had a 4-bar, but with these, we just kind of wanted to basically Metabot on the front and VEXU on the back, where we would just have a match loader for skills and stuff like that. So this is a 900 RPM, just 6-piece sprocket up to flex wheels. Here, I'll run it. And it worked pretty well. Never had any problems. We had pistons that could pull it up for our A-tier hang, shift our center of gravity in. We have a frog on the front. Shout out Ian 51581S. Yeah, that's about it for our intake. Oh, our intake, do you want to fold this one up so that...
Oh, yeah. So this is the bigger robot. This is the 24?
Yeah, so this one could start in size.
But this one, the 15-inch one, we had to start like that.
Yeah, so for VEXU, it was kind of difficult. I think the hardest challenge with designing a VEXU robot is the 15-inch, because the game elements are kind of designed for 18-inch robots. So like for next year, this will be very hard because the thing is basically as wide as the robot. Yeah, so designing something to package up into this was hard, and that's why we have this bend in our catapult. So if you can see it basically goes straight up.
With the sleds in the back. And so then when the match would start, the catapult would pull out and it would release.
Yep. And that's why we have this at an angle. So unlike a regular catapult that would usually stop like here and it'd be flat, ours had to go all the way up to here. So we couldn't change the hard stop angle. We had to change the launch angle, yeah.
Using the TPU backstop.
Yeah, and that was kind of difficult to do, and that took a lot of
tuning.
Oh yeah.
A lot of tuning.
Yeah. Oh, another thing, we had our rubber bands kept breaking, so we put this tubing, we cut a slit in it, and then zip tied it.
All that is pneumatic tubing.
Yeah.
So we just cut a little slit down the middle, slid it over, zip tied it on.
Yep. Some other cool things about our robot. We got inertial mount right there.
And then custom tracking wheels.
Custom tracking wheels, the little Omni wheel. It's pretty wide because I used a high strength shaft to do it, but in the future we'll just use low strength. The high strength, better tolerance. I don't know.
Yeah.
Tubing. This is our hang mount. Yeah. Because we use 3-inch stroke pistons. This is just to reinforce our catapult from bending.
We bent this bar a lot.
Yeah, so then we put a high strength bar, braced it, and then braced it up. This is not going anywhere now.
It's good.
Yep. These are polycarbonate sleds. These never broke.
They didn't break.
Earlier in the season.
We haven't used these, like we used these for Worlds, and at Purdue, we were using, what was it, ABS?
Yeah, ABS.
And we broke at least 6 sleds. These haven't broke once.
Yeah.
So, way better solution than the ABS. But
yep, we have that tank mount. Oh, this is pretty cool. So, we needed to make the limit or the distance sensor mount So this is an even hole, but our chassis is an odd hole. So I have this bracket here that connects through this bracing, and that just mounts it on an even hole. That was pretty clean. These are also TPU, so this can bend and stuff, which is kind of useful because we didn't design for it to be this short. It was originally longer, but when we made it shorter, we can have it at an angle, so we can line our robot up right to the goal for my floating.
Being able to adjust this changes the way the spin is placed on the tri-ball, so then depending on which side you're on, you can change the pre-match, you can change it, determine the spin of the tri-ball out of the catapult.
Yep. Oh, for wings, they're just simple. They sit right flush with our robot right there. Worked pretty well. We definitely use those wings more. Those are very bent up now.
These are extremely effective at shoving lots of tri-balls over that center barrier quickly.
Yep.
So.
Yeah, so at Worlds we went undefeated, and we got Excellence Award. Pretty cool. And then we also got
Second place in skills.
second place skills. 10-10 destroyed
They
us.
smoked us.
But-
Not even close, but we
Hey,
tried.
second place.
We tried.
Yep. Those are robots. So this is our notebook. This is the notebook that got World's Excellence. Some basic stuff. This is our team. And then
More basic stuff.
a
game
lot
rules.
of the game, offensive strategies, stuff like that. We planned a lot of the stuff out. We did the CADing.
Solution testing.
This is our first full CAD. That's at our first tournament where we did the skills. So those are our first robots, and there's some more.
Drawings of the CAD.
Yep. So all this was done by me and Cyrus. Gantt chart. This is starting our second robot, so you can see our first prototypes with those. We actually
Pretty
started-
close to the final product. I mean, if we look at, if we compare
Yeah,
both of them, they're pretty much the same. Slight changes, but
changes to the hood, changes to
yeah,
that.
there's not a serious mechanical change.
This is when we noticed that.
We tip
Yep.
a lot.
But if we change the middle wheels out, we cross a lot better. And then for Worlds, this is our original
That's the flip
elevation.
idea.
These are our front mounts. TPU catapult basket, geometry pods. That's what it looked like for the elevation. And then, yep.
That's about it. Not
That's
a whole
it.
lot left. Yeah, just some code.
Review
Yeah.
video.
So guys, trying to figure out the inertial sensors on our robots did not work very well. These are my goofy charts.
But yeah.
That was not fun, but